Hello, and welcome to another episode of Maths in an Empty Classroom with me, Mr. Southern. This is part one of the lesson on sketching reciprocals, and in this lesson I'm going to be looking at y equals 1 over x and transformations of that function. So, a reciprocal function, we call it a reciprocal function because it's 1 over x, so it's flipped. So y equals 1 over x is the original reciprocal function. And I've got a sketch here. I'm just going to spend a couple of minutes just talking about why it's behaving this way. We have the y-axis here that the graph is not crossing. And the reason the graph is not crossing it is because x cannot equal 0, because we're not allowed to divide by 0. So what we actually have here is we have what's known as an asymptote of the graph, and the asymptote x equals 0 exists because x equals 0 is a value that the function cannot take. We cannot put x equals 0 into this function. We've also got another asymptote here on the x-axis where y equals 0, and this asymptote occurs because no matter what value we make x, we're never going to get y to be 0. So if you think about what's happening with the curve here, we're dividing 1 by a bigger and bigger number, but it doesn't matter how big we make that number, it's never actually going to be 0. It's going to get ever so close, but this asymptote exists here because the graph will not cross that line. So, what I'm going to look at now is how we can use this original reciprocal shape 1 over x to sketch transformations such as 1 over x minus 2. Now, some people like to think of this in terms of transformations. I prefer to go the route of finding the x-intercept, finding the y-intercept, finding the asymptotes, and going from there. So, if we have y equals 1 over x minus 2, the first thing that I'm going to do is I'm going to find the y-intercept by making x equals 0. And that would give me y equals 1 over negative 2, which is negative a half. So my y-intercept is going to be 0, negative a half. Now, my x-intercept, making y equal 0, if I make y equal 0, I'm saying that 0 equals 1 over x minus 2. Well, this equation cannot be solved, because if I were to multiply up by the x minus 2, I'd have 0 equals 1, which is bonkers. So what that means is that the thing we're trying to find doesn't exist. So there is no x-intercept for this graph. And then we think about the asymptote for x. Now I explained how the original asymptote of x equals 0 existed because you cannot divide by 0. Well, what we have here instead is 1 being divided by x minus 2. It's still true that you cannot divide by 0, so if x minus 2 were to equal 0, whatever value of x makes that true is a value I'm not allowed to put into the function. So solving this, I get x equals 2, and if x was 2, I'd be trying to divide by 0, but I can't do that, so x equals 2 is not a valid input to the function, it gives us an asymptote. So what I'm now going to do is draw my axes, plot the relevant information on there. So I've got my axis here, I'm going to put in a dashed blue line for my asymptote at x equals 2. My y-intercept is at 0, negative a half. So here. I have no x-intercept, so what I end up with is part of the graph here and the other part of the graph here. So that is 0 minus a half. And because the graph did not cross the x-axis, that means the x-axis is an asymptote, so y equals 0 is the equation of the other asymptote. Y-axis and x-axis. Now, again, if we go back to thinking about transformations, if we call the original function f of x as 1 over x, then what we are doing with this function we've just drawn is we're replacing x with x minus 2. So x minus 2 inside the bracket is going to move the function 2 to the right, which is why the asymptote has moved over 2 units to the right and the graph has gone with it. We've still had to find the y-intercept, which is why I prefer to take this approach when I'm sketching these. Okay. One more example then. I'm going to do y equals 1 over x plus 1 minus 2. And I'm going to approach it in the same way. I'm going to say, okay, if x equals 0, y would be 1 over 1 minus 2, which is negative 1. So I have a y-intercept of 0, negative 1. If I make y equal 0 to find my x-intercept, I will be saying that 1 over x plus 1 minus 2 equals 0. Now I can solve this equation because I can add over the 2 to give me 1 over x plus 1 equals 2. I can multiply up by x plus 1 to give me 2x plus 2. And then subtracting the 1 and dividing by 2, x equals negative a half, which means I have an x-intercept of negative a half, 0. So it's just clearly state where it's going. Okay, asymptotes for x. Now remember that we are not allowed to divide by 0. So if the denominator of this function was 0, that would be a value of x that we're not allowed. So if x plus 1 equals 0, x would equal minus 1, and that is the x asymptote. Now let's think about the y asymptote, because in this case it's not going to be 0. Now we said originally that the reason we had y equals 0 as an asymptote here was because you couldn't get 0 as a value from this function. Well, that also holds true for this part of the function here. No matter what you make x, this is never going to be 0. And if this bit can't be 0, y cannot be minus 2. So the other asymptote is y equals negative 2. So negative 2 is a value that we're never going to get from this function because this bit cannot equal 0. So I now have all the information that I need to be able to sketch this graph. So let's get a set of axes. I'm going to draw the asymptotes on with dashed lines. The x1 is at x equals negative 1. The y is at y equals negative 2. It's going through the x-axis at negative a half, 0, which is here. It's going through the y-axis at 0, negative 1, which is here. So it's going to be going through like so, and like so. So x-axis, y-axis, asymptotes are y equals negative 2 and x equals negative 1. And I have negative a half, 0 there, and 0, negative 1 there. So there we go. Think about intercepts, think about asymptotes, and that's how to sketch reciprocals. Join me in the next video where I'll be explaining how to sketch reciprocals where instead of being 1 over x, it's 1 over x squared. I'll see you then.